In this video, we're going to talk about graphing exponents and logarithms. When given the function f of x equals 2 to the x, we see that this is an exponential function because it has a variable in the exponent. So if I pick some graphing points, -1, 0, and 1, and I substitute these values of x into x in my function to get the f of x values or my y values so I can plot my coordinates. So 2 raised to the -1 gives me 1/2. 2 raised to the 0 will give me 1, and 2 raised to 1 gives me 2. So so now I can plot points. At -1, I have a positive 1/2. At 0, I have 1, and at 1, I have 2. And from our knowledge of functions, we know the exponential function, the general shape of it. And then a few important things to remember about our functions is we're going to be asked to find the asymptotes. And in this situation, the asymptote is the kind of imaginary line the function is approaching but not crossing. Here we notice that our function is going to the line y equals 0. The domain of our function, if we look at the negative x values, our function will hit all of our negative x values, and then we look at our positive x values and it will hit all of our positive. So our domain is x is an element of all real numbers. You should remember these symbols from a previous course. This E looking symbol represents element, and then this R looking symbol represents all real numbers. So then the range, look at the negative y values. My function will never reach a negative y value, which makes sense seeing it's approaching the asymptote y equals 0. But it will hit all of my positive y values. So for the range, y is greater than 0. Notice I almost said greater than or equal to, but since my function will never approach the line y equals 0, it is just y is greater than 0. So if I wanted to graph the inverse of this function 2 to the x, I could reflect this over the line y equals x, or I could just switch my my graphing points here. And so by switching, I would have x values of 1/2, 1, and 2, and then the inverse f of x values of -1, 0, 1. And so at 1/2, I would have 1, I would have a -1, and at 1, 0, and at 2, 1. And so as the inverse, it will maintain the same exponential looking shape. However, we know that the inverse function of an exponential is a logarithm. So log base 2 of x represents this inverse function. When we're graphing logs, we'll talk about later on how to graph logs in the calculator when we're sketching these graphs, but for now we will use the exponential functions and find their inverses in order to graph our logarithms. So the asymptote for our logarithm function, our logarithm looks to be approaching the line x equals 0. And for domain, it's hitting all of my positive x values, but none of my negative. X is greater than 0. And for the range values, y is an element of all real numbers. The last thing I want to talk about in this video is the number e. You've heard of the number pi, which represents 3.1415 and so on. E is just an irrational number, very similar to pi, and is approximately 2.718. The reason I'm introducing this is we use E in a lot of our exponential functions and when we're modeling exponential functions. And when you move on into calculus, E is used primarily in calculus, but we use it for those exponential functions. So if I wanted to graph the function e to the x, I would once again pick some graphing points, and in a calculator I would use the E button. So this e to the x right next to the 4, and I would use it to find my y values or my range values. So at -1, e to the x is 0.378 approximately. To 0 it's 1, and at 1 2.718 approximately. This is me rounding. So at -1 I'm going to plot a point approximately at 0.378. At 0 plot a point at 1, and at 1 approximately 2.7, which is close to 3. Since e is an exponential function, it does follow the exponential curve. And that's my function e to the x. Now to find the inverse of that, we would once again switch the x and y values and plot those points. So at 0.378 I'm at -1, at 1 I'm at 0, and at 2.718 approximately I'm at 1. So we notice here in the inverse function of e to the x, it looks very similar to a logarithm. And since e to the x is an exponential function, it is a logarithm. However, the inverse of e to the x is not log base e, but rather the natural log of x. This is just a special name for the e to the x logarithm. We use both of these in solving the different exponential equations we use to model.